going to go through integration, topic 15.1 to 15.3. Alright, so let's talk about integration and why do we actually use it and what. Alright, so integration is really the reverse process for differentiation. So it's still part of calculus chapter. Yeah? And integration is very useful for us to find the equation of function given that we know the gradient function or the dy dx. Other purposes includes finding the area and volume under a curve, all right, specifically when you're using definite integral. Now I'm going to explain to you all these different terms, what is indefinite, what's definite integral, and we're going to go through some examples to help you to really understand that. All right, so let's talk about differentiation as integration, as a reverse process of differentiation. All right, let me annotate here. So when we talk about differentiation, for example, dy dx is 4x. If we want to work out by hand what is our original function, now it probably is something with regards to x squared, right? Because now the power here is power 1, so maybe it's like 2x squared. So when you differentiate dy over dx, here you should get 4x, something like that, right? So essentially the process of integration is to kind of help us to get from here to here, but we want to have a more systematic way of doing it rather than we just kind of guess. All right, so what is the general process to integrate? So integration, we will use this S looking symbol. This is the integration sign. Now if you're going to integrate some polynomials, let's say xn dx, then what we will get is basically xn plus 1. So we're going to plus 1 to the power. We're going to divide by the new power, n plus 1, and we're going to plus a constant term, some unknown constant. Now, why is this so? Because when you differentiate this function here, let me just highlight this. Yeah, when we're going to differentiate this guy, you'll notice that the c will get eliminated, all right? So that c would kind of be gone when you differentiate it, all right? So it is important that we add a c, even though the c could be 0, c could be 1, c could be 10, doesn't really matter. As long as we are doing indefinite integral, which is what we are doing here, we're going to have to add a plus c, all right? So we're going to try some examples to kind of help you to understand it better, all right? All right, let's look at example number 1. Let's see here. Yeah, so we want to find y in terms of x for each of the following. So we are actually given the gradient function for a, b, and c. So essentially what we want to do, we want to get back to the original function, the y equals to what? All right, so let's do that. So if dy over dx is x4, so if we want to find y, that means we got to integrate x4 dx with respect to x, all right? So what we'll get is actually x4 plus 1 over the new power, which is 4 plus 1, plus c. Can clean this up a bit, so we have x5 over 5 plus c. Okay, so that is actually our y, because we are getting from our gradient function to our equation. Now, we want to prove that if we're going to differentiate y, we should get back to the dy dx, right? So let's do a quick test. We do our differentiation here. So if y is equal to x5 over 5 plus c, then dy over dx, so we're going to bring the power for 5 down, so 5x. The power will remove 1, minus 1, so it becomes 4. And then over 5 still exists there. We didn't really do anything with it over 5. The c will be gone. C is just some value, right? 2, 3, 5, 0.5, 0.6, half. So that will be gone when you differentiate it. Clean this up a bit. You see that the 5 and 5 will get cancelled out. So we'll have x4, which is exactly what we have in the beginning. All right, so this is just kind of how we checked it, that our integration is perfect. All right, so you can pause the video here for a while and try it yourself. Try B and C. We can check through the answer once you're done with it. Then you can unpause and you can see the process. All right, you can pause now. Okay, so Now I'm going to show you how to solve B and C, and I want you to check your answer, make sure you are right. All right, so let's see. If dy over dx is root of x, so essentially that is equals to x to the power of half. All right, so you're going to integrate x to the power of half dx. So what we will have here is x 3 over 2, because 1 plus half is 3 over 2, divided by the new power, 3 over 2 plus the c. Clean this up a bit, so we have 2 over 3x to the power 3 over 2 plus c. Okay? So let me know if you got it, right? Okay, part C. All right, maybe I'll do it over here. X, dy dx is 1 over x cubed. Okay, so dy over dx is 1 over x cubed. So essentially that is actually x to the power minus 3. All right, so let's integrate this guy. Integrate x to the power minus 3 dx. So y is equals to x to the power of minus 2, because minus 3 plus 1 is minus 2, divided by minus 2 plus c. So we should have something like y equals to 1 over, put a minus on the outside, 2x squared plus c. All right, so that is how we do this 3 example. Let me know if you got the answer, all right, in the comment down below. I would love to see that you guys can actually solve example number 1 by yourself. Okay, so let's look at further examples. Example 2, same thing. We want to actually integrate this 3 gradient function to get to y, all right, the original function. So A, I'm going to do here, and then I'll do B and C. Now, if you want to try it yourself, you can pause the video right now, try it, and once you're done, you can actually unpause and check to see if you got the answer. All right, I'll let you pause first for now. Okay, so let's check your answer. Let's see if you got it. So if dy over dx is 6x squared minus 5 over x squared plus 4x. So if we're going to integrate this whole thing with respect to x, so we do expect ourselves to get something like 6x cubed over 3 minus, so this is 5, this will be x minus 1 over minus 1. All right, and this will be plus 4x squared over 2 plus a c. All right, so let's clean this up a bit. So we should have 2x cubed plus 5x to the power minus 1, or some of you will put 1 over x, it's fine. This would be plus 2x squared plus c. All right, now let me know down in the comment if you got this answer. Okay, part B, let's try this. All right, so dy over dx is 8x cubed minus 4 over 3x to the power of 5 minus 2. All right, so let's integrate this guy. 8x cubed minus 4 over 3x 5 minus 2 with respect to x. So we will get something like 8x to the power of 4 over 4 minus 4, we'll have minus 4, I believe, as our new power, divided by 3x to the power of minus 4. Okay, and minus 2 will be gone, or would it be gone? No, actually we will add the x at the back. So minus 2x, all right? I'm going to plus a c here. All right, so very common, student when they integrate, they will remove minus 2, they'll think that it's like differentiation, but no, actually, you have to put back your variable, in this case, x. All right, so from x power 0 to x power 1. All right, let's clean this up a bit. So we have plus, how much is that? 16 over 3? 16 over 3, x to the power minus 4, or some of you will put x, 1 over x4, that's fine, minus 2x plus c. Alright, so this is how you solve for part B. Let me know if you got it, alright? Okay, now C is a bit more complicated. We have not enough space. It's okay, we'll do it over here. C. Alright, so dy over dx is x minus 2, x plus 5 over root x. So what I'll do actually before I integrate, I just want to expand everything out. So I have something like x squared plus 3x minus 10 over root of x. And I'll further simplify that. So that is x to the power of 3 over 2 plus 3x to the power of half minus 10x to the power minus half. Okay, so I don't really like to integrate with a fraction, and there's no such thing as quotient rule or a product rule when it comes to integration, all right? So we kind of need to expand everything out and really then work that out from there. Okay, so let's integrate this whole thing. X to the power 3 over 2 plus 3x to the power of half minus 10x to the power minus half, oops, with respect to x, okay, so minus half. Okay, so we should get this to be x to the power of 5 over 2 divided by 5 over 2 plus this one will be 3x to the power of 3 over 2 divided by 3 over 2, and this will be minus 10x to the power of half divided by half plus c. So this will be 2 over 5x to the power of 5 over 2. This would be plus 2x to the power 3 over 2. And this one would be minus 20x to the power of half plus c. Alright? Sorry, it's a bit small, but I hope you got the same answer. Alright? Okay, that's example 2. Alright, example 3, let's look at that. Alright, so this is more of like a question involving some sort of a story, but it's essentially the same thing like what we have done. And the good thing is that they've given us a point on the curve. Why do we need this point on the curve? Actually, it is to help us to find the unknown C constant. All right, I'm going to show you how this is done. All right, so let's look at the question. A curve is such that the gradient function is 1 minus x, 3x minus 2, and 2, 8 is on the point of the curve. Find the equation of the curve. All right, so let's state that dy dx is 1 minus x, 3x minus 2. We want to expand it a bit, so we have something like 3x minus 2 minus 3x squared plus 2x. So minus 3x squared plus 5x minus 2. All right, so let's integrate this to get our original function with respect to x. All right, so what we'll have here is minus 3x cubed over 3 plus 5x squared over 2 minus 2x plus c. All right, so that is actually our equation. Unfortunately, we don't really know the c value, so that is why we need to substitute 2, 8 in to get the c value. So I'm going to sub x equals 2 and y equals to 8. So let's put it in. So 8 equals to, this is minus 8. Let me work that out. 4, 20, 20 plus 10, minus 4 plus c. Okay, something like that. So let's work out c value. So how much is that? 16, 6, 10. So c is 10. All right, so let's rewrite this. So this will be y equals to minus x cubed plus 5 over 2x squared minus 2x plus 10. Okay? Now, this is how you solve it. Alright, so I've given some questions in your Firefly. You can try those questions and see if you can get the answer. You can always check your answers at the back. Alright, so you can pause now and you can rewatch it later for the next part.